Hi everybody, today we're looking at the chi-squared goodness of fit test for uniform distributions with Minitab. The chi-squared goodness of fit test is a statistical method used to determine whether a sample comes from a population with a specific distribution. When applied to a test of uniformity, it checks whether all categories or classes in a dataset occur with an equal probability. Think like flipping a coin or rolling a dice. We want to know if the data fits this type of uniform distribution. So when do we use a chi-squared goodness of fit test for uniformity? First, our data needs to be categorical, or maybe we've grouped it into discrete classes. Then we need to expect each class to occur equally likely under the null hypothesis. We're also required to have at least 5 expected observations per class. This ensures validity for the test. So let's talk about our hypotheses. Our null hypothesis says the data follows a uniform distribution. Then our alternative hypothesis will be that the data does not follow a uniform distribution. We have multiple steps we need to follow in this hypothesis test. To start, we need to collect our data, summarize it into a frequency table to make things easy to work with. We refer to the observed values as O sub I, to say we have multiple different values that we're looking at. Then we need to calculate the expected frequencies. Because this is a uniform distribution, we write E sub I is equal to the total number of observations divided by the total number of categories. Let's take a look at the formula for the chi-squared test statistic. Chi-squared is going to be the sum of the observed value minus the expected value squared over the expected value. The subscript I in the calculation shows we do this for each of the different types of outcomes. But luckily, we will get to use Minitab to find this test statistic and to find the p-value, so we won't actually be calculating chi-squared ourselves. We need to know the degrees of freedom for our chi-squared test. It will be the number of categories minus 1, and we'll call that df, just like we have with other tests and distributions. Once we've collected all of our data, found our calculations, we can compare the p-value and make our conclusion. So let's look at an example about gear teeth defect inspection. An engineering team at a gear manufacturing plant wants to check whether defective teeth on gears occurs uniformly across the gear quadrants. A gear is divided into 4 equal quadrants, and it's expected under normal wear or manufacturing that defects should be evenly spread, which means uniformly distributed. So our hypothesis is that the defects are uniformly distributed across the quadrants. The alternative hypothesis says the defects are not uniformly distributed across the quadrants. We're going to use a significance of alpha equals 0.05 for this problem. Now let's take a look at the data. The engineers inspect a sample of 120 defects and record where each occurred. In our table, we can see a defect occurred in quadrant 1 25 times, in quadrant 2 30 times, in quadrant 3 40 times, and in quadrant 4 25 times. Because we have 4 categories, our degrees of freedom are 4 minus 1, which is equal to 3. Let's take all of this information over to Minitab. To start, I entered my data into column 1 and column 2. Notice I labeled column 1 quadrant, and I put in the values 1, 2, 3, 4, and then column 2 I labeled frequency, and there's 25, 30, 40, 25. Now we're going to hit Stat, go to Tables. Then you're going to select the chi-squared goodness of fit test 1 variable. Our observed counts are in column 2, which we labeled frequency. And then our categories are in column 1, which we call quadrant. Make sure that your test is set on input column and that you've selected equal proportions. Here's what Minitab gives back. There's our category, there's our observed frequency. We can look at our test proportion. Remember, it's uniform, so they're all the same at 0.25. The expected is also all the same at 30. Remember, with the uniformity, we expect the same thing to happen for each of the categories. So 120 outcomes divided by 4 means we expect them each to occur 30 times. Then when we continue to scroll down, you can see the chi-squared test. We see our 120 data values with a degree of 3 gave us a chi-square of 5 and a p-value of 0.172. If you need more decimal places, click on the chi-square test box, hit the drop-down arrow, go to table options, and then you can put in the number of decimal places you want. Let's try 4. There are more charts underneath the data. They show you things like how our observed values compare to the expected values. But let's go back to our hypothesis test. Remember, we wanted to use alpha equal to 0.05. Our p-value is 0.1718. Since our p-value is greater than alpha, we fail to reject the null hypothesis. There is not sufficient evidence to conclude the distribution of defects is not uniform.